In my previous lesson, I have explained about resistance, the definition and the unit of the resistance. I told you that we will learn little more about the resistance. In this lesson, we will know little more about the resistance, how this resistance is getting affected and what are the factors affecting the resistance. Okay, so resistance mainly is affected by the length of the conductor, resistor, area of cross section of the resistor, and material, type of material, and temperature. Temperature is constant. If temperature varies, even the resistance varies. So now first, how it is how the length and resistance are getting affected. If length of the conductor is more, then resistance is also more. So more length and more resistance. Therefore, resistance is directly proportional to length of the conductor. So now this is the conductor, and if the length is more, then what happened? More resistance. Okay. So length is area of cross section. Length is inversely proportional to area of cross section. Area of cross section means the thickness. We can say thickness of the wire. The thickness of the wire, sometimes we call it as a area of a cross section. So if the thickness is more, resistance is less. If thickness is less, resistance is more. That implies the resistance of a conductor is inversely proportional to area of cross section of the resistor. And say you can see the example, if the train door is wider, then people go into the train very freely. The more people can enter without any resistance. Okay. So like in the same way, if the wire is thicker, what happened? More electrons can flow easily. Therefore, resistance in opposing the current is less. So now let us go to another factor. Resistance is L upon A. Material, of course, it affect material. It depends on the material. Okay, copper, silver, iron, all these things are having effect on the resistance. So when you add these two relations, R is proportional to L and R is inversely proportional to A, you will get R is L upon A, and if you make it is equal to, you will get constant of proportionality. This is a sigma type rho, and that is known as, rho is known as resistivity. Also specific resistance, resistivity of the conductor. Okay. So this resistivity, so how we can find out the resistivity of a conductor? Resistivity is equal to R into A. From this relation only we got this, R is equal, rho is equal to R into A upon L. Okay. So then what is the unit of this resistance? In the place of R, ohm is to be written. In the place of area, m square, square meters are to be written. And here in the down in the denominator, in the place of L, we can have m, and this 1 m will cancel in m square. Therefore, you will be getting ohm meter. Ohm meter is the unit of resistance. So in my next class, we will learn few more things.